Okay, cool. So last time we left off, we actually had like a prompt loaded. Okay, now just delete this because we don't need. I want to kind of just start over. No save deletes. Okay. So we actually created a prompt here that actually set up the um, LLM to start responding to messages in a certain way. And the way we did it was to just inject all of this stuff into the command line, send it as a normal message, and then LLM would all of a sudden start outputting these types of JSON responses. Okay. So really, that is sort of the basic, I guess, approach to what we call prompt engineering. You're kind of like controlling your LLM to start behaving a certain way. In this case, spitting out more code, which is going to be JSON. That's great and all to do it manually, but there's actually, an open question in that how are we actually going to do this from Study Buddy, like our Python program, right? And instead of showing you how to actually code that today, we're actually going to take a little bit more of a tangent and then understand how we can pass data back and forth between our system and the LLM. And we do that through REST API. And if you remember, we had a diagram showing basically a server on one end and then our client on another end sending messages as HTTP requests and getting back results as a HTTP response. This server is basically the LLM, and your requests are basically the chat messages, and the responses are the LLM responses. And it's all formatted in JSON. So let's see how we do that. So first things first, Ollama, you can go to ollama.com. You can actually go to the GitHub and find the REST API documentation. And that is actually the documentation you really need to start sending HTTP requests to your Ollama server. Okay. And in this case, what we really want to focus on is this whole generate chat completion, I guess, endpoint. They're calling it endpoint, but I'm calling it just like a REST API. So the specific API is going to be an HTTP post request where the endpoint is /API/chat. And the parameters it's going to take is pretty basic. It just has, I think, 3 that are absolutely required, and then the rest being very optional. In this case, we're going to choose to work with just 2 of these parameters. And then we're going to also set one of these parameters, and that'll be false. Okay. How does this all look like? Oh yeah, one thing to note is that these messages here. So actually, let me back up. So in all of these parameters, think of these parameters as like a dictionary or like an object. Okay, every one of these parameters is like a key. They lead to some value. This value could be like a number or a string or even an object. Okay. Now, for model, it's actually the model name that you want to run. And in this case, it's the same model name as you would put when you do the Ollama run thing to start Ollama and your LLM. So in this case, if I were to do something like Ollama run llama 3.2, then I go 3b instruct q8_0. This one here is your model name. So that is a string. This whole thing here is a string. And messages is actually an array of some other object. And it's important to know that LLMs take in these types of message objects and then kind of parses out that content to determine what you're actually sending it, right, as a message. And each of these message objects are actually defined here. So it's basically a simple object that contains 4 properties total. One is going to be the role of the message, meaning who is the message coming from. If the role is a user, for example, and this is a string, that means this message corresponds to a message sent from a user. Now, if we have an assistant role, it means that this message is actually sent from the LLM. Okay, and you're asking like, why would we need that, right? Answer it soon. And tool is not going to be used, at least for our project. So let's just put that aside from now so that we don't have any more complication. Role, the system role is very important. So the system role, it corresponds to a message that is pretty much a message that tells LLM what to do. And the LLM is not going to respond to that message. Okay, so if you send a message with the system type, you should expect that the LLM will read it and do what it needs to do based off of that message, but it won't respond back with any response in this case. So the user will not ever see any response pertaining to that system message. The content is going to be the contents of the message. And let's just forget about images and tool calls for now. Okay. Finally, the other parameter that we're interested in is the stream parameter. It's just a flag, true or false. Basically, if you were to ever use an LLM such as like ChatGPT, you'll find that whenever you chat with someone the LLM, and you get a response, you'll see like the text kind of come in real time, like one by one. Those are like what we call the tokens. That's in streaming form, where it's in real time as the LLM is generating a new token. It's just spitting it out to you so that you can see it. It looks like it's like talking to you in real time, when in fact it's just because it was just take forever on most systems to just wait for the LLM to generate an entire response and then send it out to you in one shot. Okay, so normally we would stream the responses. But in this case here, we want to set it to false because we just want to understand how the API works. We won't even think about streaming responses because our responses are going to be pretty simple. They're just going to be simple JSON format. So we don't have to deal with any complexity in handling streaming responses here. We'll just set that to false.
Okay.
Yeah, cool. So I'm betting you still have like an open question. It's like, okay, so how do I even like structure this, right?
Yeah.
Yeah, because it's like right now it's just like a wall of text with bullet points. It's like, what does it even mean? And then you probably have a question like, you still probably don't understand what the heck, like, why would you need a system and an assistant message inside your like messages list? And I can explain that too. It's all going to make sense once we start like writing our HTTP requests. So let's actually take a look at how we can actually build one of these requests manually. And I'll just make a new file called notes. Yes, I'll just add to Git. Okay, so how a request to LM to an LM looks like. Okay, so first of all, we have our endpoint, host, API, chat, correct?
Yep.
Yeah. Actually, that's not what you're supposed to be really be sending. You want to actually construct the entire URL. Okay. So in this case, the LLM that you want to interact with is a local LLM, meaning that it's on your computer. In this case, my laptop right now. And the server is Ollama. That's like the front end for the LLM. Now, Ollama is listening on a specific port, 11434. That's the port, okay? Ollama listens on by default. 11434. What you need to do is send HTTP requests to this specific port. So you'll find that your server is, of course, localhost, and then the port is going to be 11434. that will be basically your hostname, right? So that's going to be the server that you want to actually start sending requests to. And the endpoint is this endpoint here, this API chat. So you're going to do API chat like that.
Okay.
Yeah, that's like the full URL. And so you want to make post requests. Okay, so that's cool enough. But what about like all that other junk that I just explained? Like this model, this messages, all this stream being false. How is that actually sent? Well, you want to send the data with this request, okay? And this data is going to be that JSON. So you're going to find that it actually just looks like a dictionary. So in this case, model is one of the required fields for this request. And in this case, for my laptop, I'm going to be using Ollama 3.2. I'm going to use a 3 billion parameter model, the instruct variant of it, and the 8-bit quantized version. So that's going to be my model name. Next, we'll specify that we don't want to stream, okay? And then finally, we're going to actually add some messages. So I am going to initialize this as a list, okay? It's an array, it's a JSON array. And then each item, which is a message, okay? Just to remind ourselves, a message just has, in our case for today, 2 properties, role and a content.
Okay.
Now, yeah. So far so good, right?
Yeah.
Yeah. So that's the reason why I actually create this empty object in here within this list, because we're going to fill it up with the right properties. So in this case, I'm going to say the first message I'm going to put is going to be user. So the role user, and the content, I'm going to say hello there, or hello there. Okay. So this is basically a request, a post request to send to an LLM to chat with it, containing only one message. And you might be going, one message? Isn't that how it always is? So one thing to know is that LLMs are stateless. So basically, if you were to kind of talk to it by sending one of these requests, and then you get a response back, and then let's say you get that response and you respond to the LLM through sending it another one of these types of requests, and instead of this content here, you go like, this is my response to your message, LLM. Okay? Your LLM, when it receives a message and responds, it'll be like, I don't know what you just said. I really don't know what you meant here. Okay? Because the thing is that LLMs are stateless. They don't have recollection of any past requests you've sent it at all.
Okay. So it's like the LLM having amnesia. Once I send something, it like processes it and then it forgets.
Yeah, exactly. Because
Okay.
it's job. Okay, so it's super important to remember that an LLM is not like all knowing or AI in this case. Its job is to only generate words. And when it has generated a response based off of your message from the user, this user message here, it has done its job. Okay. And it's going to send back its message as the role assistant.
Okay.
Okay, so here's where it gets really interesting. In order for you to maintain a conversation, okay, you have to include with your latest message the entire history of all the other messages that you have sent and the LLM has responded to you in the past inside this messages array here. So let's say your conversation was like 10 messages long, and then you sent another message. Okay, this messages array is going to be 11 of these types of things.
Oh, like
Yeah,
a history?
a history. Yeah. So
Okay.
the reason why is that in order for the LLM to understand your latest message to it, basically the 11th message, it's going to actually look back at every single one of these messages here to kind of understand its conversation history. Meaning, okay, what did the user initially said? What did I initially responded with? What did the user say after that? And what did I respond with? I being the LLM, what did I respond with after that? And it kind of just starts to build this summarization in its like memory. And then when it finally reaches your latest message down here, it's gonna know exactly how to respond.
Okay.
So it goes like, it tries to understand everything within this list. And that's the reason why there's like a system message, there's a user message, and there's like an assistant message role. Because it needs to know which one was you and which one was it as it looks back in history.
Okay.
Right? So it's kind of like a play, a transcript in this case. You need to send the transcript back because the LLM can't remember anything at all.
Got it.
Yeah, okay. So you know that part, right? So this is like the reason why you need to send back, or this is the reason why we need to distinguish between like a user message and an assistant message.
Yep.
Yeah. Okay, now here's like the final message type. The final message type that we're going to be concerned with is going to be the system one. Now, usually, like I said before, your LLM doesn't remember anything at all. And so if you had initially sent a message to tell it to behave a certain way with a system message, you have to actually maintain that also in your messages list. Like the first message here will be your system message, because it helps remind it the rules to how you want to converse with it. Does that make sense?
Yeah.
Yeah, because if you don't include it, then on the next time it responds, it's gonna forget what it was supposed to do.
Okay.
Yeah, so like you're kind of laying down the rules for it in every single request, literally. Like in every single one of these things, you always have to send back that system message to just like kind of give it like a reminder of the rules of the game.
Okay.
Yeah. Okay, so let me just demonstrate all this. Okay, so let's actually talk to our LLM without any UI, just pure HTTP. It's gonna be fun. So what I want you to do is make sure you have this tool. I don't know if you ever used Postman before, but I'm sure you've used curl when you install stuff on Linux. Bruno is kind of like a front end for it's like a UI version of curl. What you can do is you can send like HTTP requests and see like its responses, and you can like build them manually with a UI. It's a really good tool. I think it's free. It's not like Postman where you have to log in with anything. And a lot of these big companies here use it. And it works on Linux. And it treats Linux as like a first-class platform. See,
Okay.
it's so first-class that Windows is the last class here. Right? So, okay. So, yeah, I've already installed it. And when you're, oops, that's okay. When you first start Bruno, it will want you to create a collection. A collection in this case is just basically a project, okay? And you'll save it to like a folder. It'll ask you to save it to a folder. What you can do then under this collection is create different types of requests so that you don't have to always manually rebuild them. Does that make sense?
Mm-hmm.
It's like during testing, you can just like tweak things and send it off and things like that. Okay, so I already have created my first request here. It's going to be the post request, and I just named it. It's a label, chat with LLM. So if you were to do new request, I could say chat with LLM demo like this. And then I can specify it's a post request, but post request to where? I'll say it's HTTP localhost, and that'll be the port to Ollama with the API endpoint like this.
Okay.
Straightforward, right?
Mm-hmm.
Okay, so right now we have this request all ready to go, but we don't have that body. Like we don't have that data, this specific piece of data here, this JSON that we want to send. So what we can do is we can actually go to body here, okay? Specify that we want JSON. Okay, so that basically internally adds a header. Like it's like a content type header, for example, like this content type. It just manually adds or automatically adds this thing here to your HTTP request. You can do it manually, but by specifying JSON, it'll do it for you.
Okay.
So that tells the server how to interpret your body. In this case, if you said JSON, it'll parse that JSON. The servers, it's up to the server to have that support. Okay.
Yep.
In this case, Ollama does. Does that make sense?
Yeah, that makes sense.
Yeah. So if you flip to JSON, you'll automatically have that header in place by Bruno. Anyway, let's just send the JSON. So I'm going to specify the model, and that's going to be llama 3.2 3b instruct q8 underscore 0. I'm going to specify no streaming. And then I'm also going to add a message into the message list. It's just going to be a little simple hello message. So the role is going to be the user, okay? And then the content is going to be hello there, okay? All we need to do to fire this request is just to hit this button here, this arrow button.
Okay.
And then the request will go through, and it's going to take a while because I'm on my laptop and I have no GPU. It's all on CPU. So I get back a response. It says, hello, it's nice to meet you. Is there something I can help you with, or would you like to chat? Okay, so now under normal circumstances, let's say in the real world, okay, what you want to do is that when you get this, when your program gets this response back, you want to parse this out and kind of just save this part here, okay? Because the next message I send must also include this message. So like in your code, you want to kind of extract this object out of your response and append it to your messages list like that. Like this, if that makes sense.
Yeah, that does.
Yeah, you want to just maintain that, right? So that's how you can maintain a coherent conversation, or cohesive in this case. So if I were to say user, I'll say I am having problems with taking care of my orchid plant. I think it is dead. Okay. And so I can send that request back to the LLM. And given that I have sent the entire history of our messages, the LLM should know what I'm talking about here. It'll look into this and it'll go, oh, I'm not sure what you're talking about, but I have all this to follow. So it should be good. So if I were to send this request again with all of this data, it should actually respond back to me with something that deals with learning how to take care of an orchid plant or something like that. So
I actually have a question. So like how many messages can we send before it maxes out?
okay, yeah, okay, that's a good question. So every single model, like for example, let's say Llama 3.2, okay, they have internally what we call a context window limit. And the context window is basically the number of tokens the LLM actually considers in a message before it stops to try and understand any more of it. Okay, so let's say that you had an LLM that is a context window of 100 tokens. Okay, and just to simplify things, let's say that a token is a word. So we'll say the context window is 100 tokens, meaning it's 100 words. So what that means is that when the LLM is looking at all these messages here, it's actually only going to look back 100 words to try and formulate the response, because it cannot look back further than that.
Okay.
Yeah.
Got it.
So that is generally your limit. Okay. Now, suppose you're not keeping track. Suppose that you're always going to be appending messages over and over again. Your LLM will automatically only look back and not consider any more of that. Okay. And in the industry, there are several tricks to get around this where, like, okay, if I know that I only have 100 words, but now I'm approaching like 300 words instead, I would summarize the previous messages to get it down to only 50 words and send that instead as one message.
Okay.
Yeah.
Thanks.
So this way the LLM can maintain at least some form of the conversation history. It's not ideal, but it works ish. Okay, so let's look at what the LLM responded back with. It looks like it's a reassurance message. Don't worry, it's not uncommon for people to struggle with taking care of orchids. Okay, so just by reading that, I know that the LLM has maintained the conversation. Okay, so if I were to copy and paste this, this is actually the entire flow of the message, or at least the chat before my next response, right? So whenever I want to respond again, I will just append another message here with the role user and continue the conversation that way. Does that make sense?
Yeah.
Okay. So it's my next response. Da, 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 da. Okay. So that's why you have messages as an array instead of just a single object, because you need to maintain the entire history. So let's just do this example chat with context to maintain. Okay. Okay. So what happens now? Let's say we didn't maintain any history. Okay. Let's say we didn't append messages. What's going to happen? So let's say I started off the conversation with "Hello there." Oops. Oh, and I'm gonna I guess mention the driving point of all this. Okay. Literally, you can alter history of your chat by just going into any one of these older messages and just modifying it. You could literally trick the LLM to thinking that that was what it responded with. This is actually very useful for some certain cases where systems can start to detect that a conversation is kind of going a little off in terms of like appropriateness in the enterprise world. So you can have something that will scrub any inappropriate things to kind of just like rewrite the messages, like scrub messages away from like bad things, and then the LLM on the next round would actually not be aware of that, thinking that it was all like clean, and it respond accordingly. You could alter the history. It's like me telling you that you said something like 3 years back, but you didn't, and you believed me, and then you went and kind of just did the next thing based off of that. Does that make sense?
Okay.
Yeah.
Yep.
Yeah. So the LLM, like for the LLM, this messages list is like the source of truth. Okay. So if I were to send this message, and this is why I guess this helps to be on the GPU. But anyway, so okay, LM goes, "Hello, it's nice to meet you. Is there something I can help you with, or we'd like to chat?" Okay, and let's say you didn't maintain any of that, and then you're gonna send the next message. I'll say, "I am having problems taking care of my orchid plant. I think it is dead." Okay, you'll find that the response is still going to be appropriate because I'm still very detailed on what I want. So it'll still kind of want to talk about orchids. Okay. But I'm going to purposely sabotage a conversation by giving it something else, but still relate it as like what you would respond to a person who has context of the conversation. So just let's see what happens after this response here. Yeah, as you can see, as the message it needs to generate gets bigger, it puts more effort, and it gets harder for it to generate new things. So that's the reason why long conversations tend to become slower and slower, because it has to like look back very far and generate off of that. So same thing with its own messages too. As it's generating longer messages, it gets harder and harder for it to come up with something.
Okay.
Yeah.
Mm.
And what's interesting is that for this laptop, it is an older laptop, but this is only a 3 billion parameter model. So.
Like if it's too long, would it time out, or like how would that work?
Yeah, so that depends on your server, really. It's up to the Ollama's configuration to have a timeout, and I'm thinking it's going to be like 2 minutes. So if I were to do this, so it's on 100% CPU. I think Ollama will time out in like 2 minutes. I think by setting.
Okay.
Yeah, but let's just see. Let's just see. It's curious to know. Okay, not 2 minutes. It's working. I'll trust that it works.
Oh yeah.
I'm just gonna let it go. If I ever look at like BTOP, for example, you'll see that since it's not using a CPU or GPU, it's using my CPU, and it's just like cranking really hard right now. Look at this. Yeah. So Ollama is taking up like 25% of my CPU. So, and that is about, if I had, I guess, 16 cores, that's definitely four of those cores and threads. Sorry, I have 16 threads, so it's taking up 4 threads. Like, I guess we'll call balls to the wall. But I'm not gonna give up on it. gonna let it process.
I have a beginner question about the default port number. Like instead of 11434, like how would I get another number if I wanted to, or is that out of the question?
No. That's possible, right? So this is very useful. That's why we go to the Ollama documentation. Okay. So what we can do here is we can probably go to something called troubleshooting or FAQ. We can do FAQ maybe, and we can search for port here. So here we go. Ollama binds 127001 port 11434 by default. You can change the bind address with the Ollama host environment variable. Okay, so what you can do is you can set this environment variable of the Ollama service with the host : port you want to listen to. Okay, in this case, since we're waiting for it, I'm going to show you what it looks like. Ollama is a service that runs under, I guess, systemctl, whatever you call it. So you can do, let me try to make this bigger.
I could see it.
Oh, you can see it? Okay. Yeah. So I could do something like systemctl or sudo systemctl edit Ollama.service like this. And then you'll be presented with this text file here where you can actually add more variables. So I only have one environment variable right now called Ollama keep alive equals -1. You can add another one by going environment equals Ollama host. And then you can specify your IP address, the port you want. So in this case, let's say I want to go for port 8800. I would just do something like this. Or in this case, I want to listen to all the interfaces. I would do this, 8800. Oops. Like this. Okay. And then what I would do after that, I'm not going to save it. I would do sudo systemctl stop Ollama service to stop the service, and then I would start the service again with the new settings.
Okay, got it. Thanks.
Yep. Okay, so oh my goodness, look at this. No wonder it took a long time. Okay, so okay, I'm just saying cool. Okay, that's cool. I'll just say okay. Okay. I'll just say okay. It gave me such good advice. I'll just say okay.
if I wanted to limit the response, would I kind of write that in under content, like, or under my question, like, oh, limit it to
Yeah,
100 words?
yeah. So that's a great thing. That would be like a system message, really. That would be like the ground rules that you set for your LLM. Like saying,
Okay.
do not respond with more than 100 words, for example, in your system message.
Okay, I think I'll
Right.
do that.
Yeah, yeah. So sometimes it just says too much, right? Okay,
Yeah.
so look, okay, so I didn't maintain history, and it goes, it seems like you're ready to get started. Is there something specific you'd like to talk about or ask? I could help with a wide range of topics from science and history to entertainment and culture. What's on your mind? So it forgot everything because we didn't maintain this. Okay.
Mm-hmm.
So this is actually how we use the API. So what we're going to do next time is we're going to then start building this manually in code and send using our request library to send it off to the Ollama server, get back that content, parse it out, and then maintain some sort of chat this way. And after that, we're going to see how we can play the study buddy, game, the Q&A game, getting those JSON responses back. So I think that's it for today.
Okay, sounds good. Thanks.
Thanks.